Hi, I'm Mr. Franklin, and today we're going to be talking about kinetic energy. Kinetic energy is energy, so it's the ability to do work, and we often represent it by either saying Ke or sometimes just K, not to be confused with the temperature Kelvin. Okay, this is for kinetic energy. Kinetic energy is the ability to do work based on an object's motion. When we say motion, we're talking specifically about velocity. So kinetic energy, represented by the symbol K, equals 1/2 mass times velocity squared. So this is the mass and this is velocity. The big gotcha when you're working your math problems is that velocity is squared. So keep that in mind as we go along. The units for kinetic energy, guess what? It's the same unit we've been talking about. It is the joule. Okay, the units for kinetic energy are joules. So if I take an object, let's say your pencil, and we raise it up a distance, so we've raised it up a distance, and then I let go. So now it's going to fall. Now it's falling. As it falls, just before it hits the ground, it's still moving, and it has its maximum velocity. So for example, let's say it reached 2 meters per second. It's going to have its maximum kinetic energy at the bottom of its fall. Now once it hits the ground, it's going to lose all of its kinetic energy, and the energy is going to turn into thermal energy, but we'll get into that later. But just before it hits the ground, it's moving at its fastest, has its maximum kinetic energy. So let's plug these numbers in. So let's say, for the sake of argument, that the mass of this object is 1 kilogram. So K equals 1/2 times 1 times 2 squared. Be sure that when you're plugging numbers in, that you put parentheses in for the variable and then put any operations on the outside of those parentheses. K equals 2 squared is 4 times 1, which is 4, times 1/2. So 1/2 times 4 is equal to 2. And the units for this will be joules. So K equals 2 joules. Now, with potential energy, we've been talking about an object being lifted. If this were an object going from side to side, if its velocity was 2 meters per second and its mass was 1 kilogram, the kinetic energy would still be 2 joules. Okay, so kinetic energy, it doesn't matter if it's up or down, side to side, it is still going to be 2 joules with these numbers. Okay, potential energy only works because we're talking about gravity, so we have to lift it off the ground for there to be gravitational potential energy. Okay, all right, so let's take a look at a cartoon that kind of explains this a little bit. So we're going to take our pencil and we're going to pretend that this is our table. So I got my table, I got my pencil, and I'm going to lift the pencil off the table. Okay? So as I lift the pencil off the table, this is panel number 1, work is done on the pencil. So I'm doing work. I've got a force times a distance, also known as the height that we lifted. Once I get it lifted all the way as far as I'm going to lift it, so let's say I lift it and I stop lifting, it now has potential energy as long as it just sits there. So I lift it off the ground and now it's sitting there, it has potential energy. The pencil has potential energy. So if I lift it up off the ground and then let go, before I let go, it has potential energy. But then I'm going to let go. And we're going to move to panel 3. Panel 3, the object is moving, it's falling. So this is 2 and this is 3. In panel 3, work is going to be done. So we're going to have the force due to gravity over a distance as the object falls. Okay? So we're having work done as the pencil falls. And now right here before it hits the ground, it's moving at its fastest. It has kinetic energy. So work is done on the pencil as it falls, and the potential energy changes to kinetic energy. Before it hits the ground is what we're talking about. Because once it hits the ground, then we're changing the story here. Okay? Okay. So let's work a couple of 7-step problems, and this might help you get an idea of what we're talking about. So R2D2 guess, an egg is dropped from a balcony. It has a mass of 0.5 kilograms and reaches a speed of 20 meters per second. What is its kinetic energy just before it hits the ground? So I've read it. Now I'm going to mark it. An egg is dropped from a balcony. It has a mass, that's m, and reaches a speed of 20 meters per second. That's a velocity. What is the kinetic energy? Okay, so K. So I've read it twice. Now I'm going to draw my story. I've got an egg. I'm going to drop it. The mass of the egg is 0.5 kilograms. The velocity, right here, the velocity just before it hits the ground is 20 meters per second. K equals question mark. Okay, so I've drawn my story. I've labeled it. Now I'm going to do my guess. So given mass equals 0.5 kilograms. Velocity equals 20 meters per second. K is, unknown is K equals question mark. What's the equation? K equals 1/2 mv squared. Plug in our numbers. 1/2 0.5. V squared is 20 squared. So we plug this in our calculator. So if you're using one like this, it's a little different. Let me turn it on first, clear. Okay, so 1/2 is basically 0.5. Okay, 0.5 times 0.5 times 20, and then you have to do the squared, which is right there, x squared. Enter. Should be 100. 100 joules. Okay? So K equals 100 joules. Pretty straightforward, pretty simple. Okay, so please watch this one because this is where most people mess up on their math when they're doing energy problems. Okay? An egg is dropped from a table. It has a kinetic energy of 12 joules. That's K, and has a mass of 0.6 kilograms. How fast was the egg falling? How fast? That's a velocity question. Just a quick side note while we're here, 12 joules. Joules is the same for potential energy. It's the same for work. It's the same for kinetic energy. Be very careful when you're labeling K because you might see joules and you have to decide is this potential energy or kinetic energy when you're on your test, okay? So be careful of that. So I've read it, I've marked my variables. Now I'm going to draw my story. So this time we have a table, and I drop the egg off the table, and the egg has a mass of 0.6 kilograms. It does K equals 12 joules of, has 12 joules of kinetic energy, just before it hits the ground, and it has, we're looking for its velocity. Okay? Given unknown equation, our givens, mass equals 0.6, K equals 12 joules, and the velocity equals question mark. Our equation is still K equals 1/2 mv squared. Do I know K? Yes, I do. It is 12 equals 1/2 of the mass, which is 0.6, and then v squared. So let's work our algebra. 12 equals half of 0.6 is 0.3 times v squared. Now I'm going to divide both sides by 0.3. 0.3 divided by 0.3 equals 1, so that we say that cancels, so we are left with v squared equals 12 divided by 0.3 equals 40. But we're not done yet because we have v squared. So the next thing we need to do is we need to square root both sides. So then we're going to, this is where you have to be careful on your calculator how you do it. And then hit enter. Should be good. So the velocity equals 6.32 meters per second. Make sure that you do the square root. If you need help finding the square root button, you can see me in class. Okay? Alright, you have a couple of sample problems for you to practice, and I will see you next time.